Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Now today we're actually going to be starting the material on MEET 3. So if you're familiar with how these videos work, then you can just skip ahead probably about a minute or two when I'm going to explain how these videos are organized. But if this is your first time watching one of these videos because it's a new competition that we're making videos on, then let me explain how IMLEM is broken down and how it works. So the structure and categories of IMLEM. So in IMLEM, there are 5 competitions total, and each competition tests different material. In each competition, there are 5 different categories. The first is mystery, then geometry, number theory, arithmetic, and algebra, which we label with a number 1 through 5, with mystery being 1 and algebra being 5 in this order. Now, I can't actually teach any of this material for mystery because, like the mystery section sounds, it's actually a mystery. You don't know what's going to be on it when you get to the competition. But for the other 4 categories, geometry, number theory, arithmetic, and algebra, I'm going to be teaching you the material you need to know to successfully compete in the Intermediate Math League of Eastern Massachusetts. Now, as for how our videos are broken down. So when I have a video, I'm going to label it like this, where I have a few numbers in a row with dots in between them. What these numbers represent is the first number is the competition number, the second number is the category, and the third one is just the section of that category. So this one, 3.2.1, would represent MEET 3, since it's competition 3, geometry, since 2 correlates to geometry in terms of categories, and then 0.1 just represents is the first section of geometry that I'm teaching you. So without further ado, let's get into the geometry section of MEET 3. So the first thing that shows up a lot in geometry MEET 3 is angles. Now angles also shows up a lot in geometry MEET 1, and I already made videos on those. So a lot of this stuff that I'm about to teach you, if you know that material, should be review, which is why I'm going to go a little bit faster than normal through this section. If I'm going too fast for you, I would recommend watching my first 2 videos in this geometry MEET 1, where I explain everything you need to know about angles that I'm explaining here, except a little bit slower. So first, let's talk about some adding up rules with angles. The first rule is that there are 360 degrees in a full rotation, which means all the angles around a point add up to 360 degrees. So in this example here, I have a point with 5 angles around it, which I'll label 1, 2, 3, 4, and 5. I don't know anything about these angles, but the one thing I could definitively say is that all 5 of these angles, when added up, add up to 360 degrees, because they're all surrounding a point. The second rule is that angles on a straight line add up to 180 degrees. So if you ever have a straight line, and on it you have an angle like this, you can always say that the 2 angles that can be created from that intersecting line add up to 180 degrees. So in this example, the way that'd be helpful is if I knew this angle was 30 degrees, then the other angle must be whatever gets it to 180, which if you do the math is 150 degrees. Now this actually makes sense because 180 degrees is 1/2 of 360. And remember, 360 degrees is 1 full rotation. So if I were to take a point and create 2 angles on that point with just 1 straight line, and then I'd be able to figure out that this angle and this angle are both exactly 1/2 of the full rotation, which means it's 180 degrees. 1 straight line is 1/2 of a full rotation, which means that's 180 degrees total. All right, and then the next rule, there's not really a rule, but it's rather a term, is supplementary. So supplementary means 2 angles add up to 180 degrees. So these 2 angles on this line, I could say are supplementary because I already know they add up to 180 degrees. And if a question says 2 angles are supplements, you can immediately say that their sum is 180 degrees. Now, a similar term to supplementary is complementary. Complementary is when 2 angles add up to 90 degrees. Now, supplementary and complementary are very similar. It's just what they add up to is a bit different. So in this example, A and B are complementary because A and B, these 2 angles, add up to 90 degrees total. Now the way that you can remember which one is supplementary and which one is complementary is if you draw an S you can see how easily this S can be converted into an 8 from 180. And if you draw a C, you can see how easily this C can be converted into 9, as in the 9 from 90. So that's how I remember supplementary and complementary. All right, now to briefly go over some equality rules with angles. The first rule is that opposite angles are equal. Opposite angles are defined as angles that are on opposite sides of a set of intersecting lines. So in this example, I have two lines that intersect, and around it I have four angles, A, B, C, and D. So if I were to try and find the opposite angles, I just have to look at what angles are opposite each other on these intersecting lines. And the ones that are opposite each other are A and D, and B and C. And the way that you can figure it out is just by tracing a straight line through the central meeting point from one angle until you reach into another. So let me show you an example of what I mean. If I started with angle A and started drawing a line here and went through the intersecting point, once I end up in another angle, which I ended up in D, that's how I know that these two lines are opposite. So from this, I can say that A and D, since they're opposite angles, are equal, and angles B and C are also equal. The next rule you need to know is that corresponding angles on parallel lines are also equal. So corresponding angles are defined as angles on the same side of a set of lines in an intersecting line. And this can be a little bit hard to understand, so in order to explain it, I actually have a diagram. So in this diagram, I have a set of parallel lines, which are these two lines here, which I drew the circle around the arrow on. And if you don't know what parallel means, it means that if they extended on forever, like this, they would never intersect. So I have a set of parallel lines and I have an intersecting line. And from this intersecting line in these parallel lines, corresponding angles are created. So some examples of corresponding angles here are these two angles and these two angles. And we know that they're equal because they have the same amount of arcs around the angle center. So this is an arc. So if I drew 3 arcs like this would mean that this angle and this angle are equal. So the reason that these are corresponding angles is because if we look at the definition, they're on the same side of a set of lines, which is the set of parallel lines, in an intersecting line. They're both on the left-hand side of the parallel lines, and they're both on the top of the intersecting line for this angle and this angle here, which are two corresponding angles. And if we look at these two corresponding angles, we can look at the same thing. They're both on the right-hand side of the parallel lines, so to the right and to the right, and they're both on the bottom of the intersecting line, which makes these corresponding angles. And since these are corresponding angles on parallel lines, and this only works for parallel lines, we can immediately say that these angles are equal. So next we're just going to talk a little bit about triangles. And the first thing that you need to know about triangles is the triangle sum rule. Now this rule is extremely important and probably one of the most applicable angle rules in polygons that you need to know. So the triangle sum rule states that the three angles in any triangle add up to 180 degrees. So if I drew a triangle right now, like this, the one thing I could definitively say is that these three angles add up to 180 degrees. And this is helpful because if you know two angles inside a triangle, say you knew this angle and this angle, you could use subtraction from 180 to figure out what the final angle is. All right, next after that, we also need to learn about a formula to figure out how many degrees there are in any shape. Because we know how many degrees there are in a triangle, there's 180, but we can actually use a specific formula to figure out how many degrees there are in any shape, a 4-sided shape, 5-sided shape, even a 100-sided shape. And that's called the N-Gon formula. So the N-Gon formula goes like this. N minus 2 times 180 equals the sum of all the angles in a shape. And what N stands for, because that's the variable in the equation, is the number of angles or sides in a shape. So for example, if I were talking about a triangle has 3 sides and 3 angles. So N would be 3. If I were talking about a pentagon, well, a pentagon has 5 sides and 5 angles. So N would be 5 if I were calculating the sum of all the angles in a pentagon. Now, how you actually use this formula? Well, first you have to figure out exactly how or what your value of n is. So in this example, I'm talking about a four-sided shape. Say I had a four-sided shape. So here's my four-sided shape. Since it has four sides and four angles, n would be 4. So I know n is 4, so I'd use the N-Gon formula, if I needed to figure out what the sum of all the angles inside the shape is. And the way you do that is you substitute in 4 for n, which means you replace n with 4. So I write out my original equation, n minus 2 times 180, which is the sum of all the angles inside a shape, and I replace 4 for n. So now I have 4 minus 2 times 180, and if you simplify this, you get 2 times 180, which is 360 degrees. So there are 360 degrees total in a four-sided shape. Now, I will admit the N-Gon formula is not that easy to remember, but I think it might be a little bit easier to remember and actually understand if I explain why it works. So the reason I taught you about the triangle sum rule before the N-Gon formula is because the N-Gon formula is actually based off the triangle sum rule. And here's how it works. So here I have three shapes: a four-sided shape, which is a quadrilateral, a five-sided shape, which is a pentagon, and a six-sided shape, which is a hexagon. And in these shapes, you'll notice I've drawn what we call diagonals, which are lines that connect different vertices or points on these shapes. Now, these specific diagonals break all of these shapes up into a specific number of triangles. So let's start with the four-sided shape. So in this four-sided shape, the quadrilateral, I drew one diagonal, which broke it up into two triangles. Now, all of the triangles' angles are on angles inside the quadrilateral here. So since I can break it up into two triangles, that means it must have 180 plus 180 degrees in it total. Because in each triangle, there are 180 degrees. So therefore, in two triangles, there must be 360 degrees. In this shape, the pentagon, I broke it up into three triangles. And since each triangle has 180 degrees in it, then it should be 3 times 180 degrees in order to figure out how many degrees are in a pentagon. And that gives me 540 degrees. And then in this last example, the hexagon, I broke it up into four triangles, which means 4 times 180 degrees per triangle should give me how many degrees there are inside this hexagon. And this is where the N-Gon formula comes from. I say n minus 2 times 180. The 180 represents how many degrees there are in a triangle. And the n minus 2 represents how many triangles a shape can be made out of. So in the four-sided shape is made of two triangles. In the five-sided shape is made of three triangles. In the six-sided shape is made of four triangles. And it's always made of two less than the amount of sides in terms of triangles. So if I did 4 minus 2, that gives me 2. If I did 5 minus 2, that gives me 3. And if I did 6 minus 2, that gives me 4. Which is why we do n minus 2 to figure out how many triangles there are in a shape, and then multiply that by 180, because there's 180 degrees per triangle. This is where the formula comes from, and that's why it's n minus 2 times 180 equals all the degrees in a shape. All right, next we need to talk about how you use the N-Gon formula in a regular polygon. So a regular polygon is defined as any polygon which has all sides of equal length and all angles of equal measure. So it's a polygon where it basically is completely symmetrical. Everything has equal length and equal measure. And you can probably think of a few regular polygons off the top of your head, like the equilateral triangle and the square. Those are examples of regular polygons. Now, because they have all angles of equal measure, you can actually do something special with the N-Gon formula in regular polygons. And here's how it works. You can find the measure of one interior angle in a regular polygon by finding the total measure of all the angles in a shape using the N-Gon formula, and then dividing the total number of angles to find the measure of one angle in that regular polygon. And if you think about it, the reason it works is because say you had a total degree measures, or total degrees in a shape of 180, which you know we're talking about a triangle here since this is the sum of all the degrees. Well, if you were to divide that by 3, because there are 3 different angles, then that will give you 60 degrees per angle since all the angles are equal in a regular polygon. And you can use this in any regular polygon to find the measure of one interior angle. Now, if you're to write this as a formula, it's actually just a very slight adjustment to the regular N-Gon formula. It looks like this, where you have n minus 2 times 180, which is your N-Gon formula, divided by n. And what this represents is the total number of degrees, which is n minus 2 times 180, divided by the number of angles, which is n. Right, we're using n a second time in this formula to represent how many angles there are. And when you divide this out, it gives you the total number of degrees divided by angles, or the total number of degrees per angles. And the last thing we need to talk about today is exterior angles. So an exterior angle is defined as the angle between a side of a polygon and an extended adjacent side. And right here, I have an example of an exterior angle. So this is an exterior angle because it's between a side of a polygon, which is this side, and an extended adjacent side. Now, what extended adjacent side means is if you take a side of a polygon, so I'll use this side as an example, and you just extend it after it meets the next side, like this, if you just extend it on, that's what you call an extended adjacent side. And when you do this, you can actually create an angle, which is the exterior angle, the one that's in between this extended adjacent side and the actual side of the polygon. Now, a rule about exterior angles is that the pair of an interior and exterior angle always add up to 180 degrees. And this is actually pretty easy to see too, because if I take this pair of an interior angle and its corresponding exterior angle, they add up to 180 degrees because they're on a straight line. See, when I extend a side and create an extended adjacent side, this line that you create the exterior and interior angle on is straight. And since we already learned that two angles on a straight line always add up to 180, this rule still applies to interior and exterior angles. Now, one rule about exterior angles in a shape that I didn't actually write down is that all the angles or all the exterior angles in any shape will always add up to 360 degrees total. It doesn't matter if it's a 100-sided shape or a 3-sided shape. All of the exterior angles always add up to 360 degrees. Now, since this is true, we can actually create a formula to figure out the measure of one exterior angle in a regular polygon. Because in a regular polygon, since all the interior angles are equal, all the exterior angles are also equal. So the formula we can use then is 360 divided by n, where n again is the number of angles or number of sides in a shape. And the reason this works is because, as I mentioned, since all the exterior angles in any shape always add up to 360 degrees, and since they're all equal in a regular polygon, if you just divide the 360 degrees by how many exterior angles there are, which is n, because the amount of exterior angles is equal to the amount of interior angles and the amount of sides. So if you divide that 360 degrees by the number of exterior angles in a regular polygon, this will allow you to figure out how many degrees there are per exterior angle in that polygon. So if we do an example, if we're trying to figure out how many degrees there are in one exterior angle in a triangle, which has 3 sides, we just have to do 360 divided by 3, and this gives us 120 degrees per exterior angle in a regular triangle. And to finish today's lesson off, I have a review question about some of the material we just learned. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll go ahead and explain the answer. So the correct answer to this question was 72 degrees. So the question asks, what is the measure of an exterior angle of a regular polygon whose sum of all the interior angles is 540 degrees? Okay, so in order to find the measure of an exterior angle, you should always work backwards in these types of questions. Figure out what you need to find first, and then figure out how you find that. So I need to find the measure of an exterior angle. And in order to find the measure of an exterior angle, I need to do 360 divided by n, because it says it's a regular polygon, which means that I need to find the value of n. I need to figure out how many sides or how many angles this polygon has. Now, the piece of information it gives us about this polygon is that there are 540 degrees total in this polygon. And I know that a formula I can use to figure out how many degrees there are total is the N-Gon formula, which goes n minus 2 times 180 equals the sum of all the degrees. So in this case, I know that n minus 2 times 180 equals 540. So now I need to figure out the value of n. And so you can do this algebraically, which you may not know how to do, which is why I'm not going to explain it algebraically. But you could do this algebraically and solve for n. But if you're just to try and figure out in your head what n could possibly be, well, first you think, okay, well, since it's n minus 2 times 180, there's 180 degrees per triangle in this shape, and n minus 2 represents how many triangles there are in the shape. So if I can figure out how many triangles there are, which is just 540 divided by 180, well, then I can figure out what n is. And if you think about what multiplied by 180 gets you to 540, you realize that it's 3. So n minus 2 must be 3. There must be 3 triangles in this shape. And since n minus 2 equals 3, then n has to equal 5, because 5 minus 2 equals 3. So since I know that n is 5 now, and if you're ever unsure about this, you can always plug it back into the equation to make sure it works. So I'm actually going to do that first before moving on. So if I plug in 5 minus 2 times 180 and simplify this, I get 3 times 180, and then I get 540. So I know that 5 is the correct value of n because I just plugged it back in, and it got me 540 degrees in this shape. So since n is 5, now all I have to do is plug n into the exterior angle equation, 360 divided by 5, and that gives me 72 degrees per exterior angle in this regular pentagon. All right, just to review what we've learned this lesson, first we started by talking about adding up rules, where we learned that all the angles around a point add up to 360 degrees, angles on a straight line add up to 180 degrees, and then we learned the definitions of supplementary and complementary, which is when angles add up to 180 degrees and 90 degrees respectively. And then we also learned a trick for remembering this, where the S in supplementary can be created into an 8 like this, and the C in complementary can easily be created into a 9 like this to represent the 8 in 180 and the 9 in 90. After that, we talked about equality rules, and the first equality rule we learned is that opposite angles are equal, which are angles that are opposite a set of intersecting lines. And then we also learned that corresponding angles on parallel lines are equal. And in order to understand this, we looked at a diagram of corresponding angles, which are when the angles are on the same side of a set of intersecting lines, or a set of parallel lines and an intersecting line. And in order for them to be equal, these two lines have to be parallel. Now we talked about triangles and the N-Gon formula. We learned the triangle sum rule, which is a very important rule which states that all the angles in a triangle add up to 180 degrees. And then after that, we learned about how to find the amount of degrees in any shape, which we use the N-Gon formula for. So the N-Gon formula is n minus 2 times 180, which gives you the sum of all the angles in a shape. We did an example with n being 4 to find how many degrees there are in a 4-sided shape, and then we explained why this works, which is that if you take any shape, you could break it up into two less triangles than the amount of sides. So a 4-sided shape could be broken up into 2 triangles, a 5-sided shape into 3, and a 6-sided shape into 4, which is why you do n minus 2 to figure out how many triangles it can be broken up into, and then times 180 as in the 180 degrees per triangle in that shape. Then after that, we talked about how to use the N-Gon formula in a regular polygon, where we could use it to find the measure of one interior angle, because in a regular polygon, every side and every angle is equal. So all you have to do is divide the total number of degrees by the total number of angles to find the measure of one angle. And the reason this works is because you're dividing the total number of degrees by the number of angles, so n minus 2 times 180, divided by n, which is the number of angles, to get the total number of degrees per angle. After that, and finally, we talked about exterior angles, which is an angle that's created between a side of a polygon and an extended adjacent side, where an extended adjacent side is when you extend a side on a little bit further than the boundary of where it meets the other sides. So the exterior angle is the one created in between the extended adjacent side and the regular sides of the polygon. And we also learned that an exterior angle and interior angle, the pair of the two of them, always add up to 180 degrees. And then since we learned that all the exterior angles in any shape always add up to 360 degrees total, we learned that the exterior angle formula to find the one exterior angle in a regular polygon is 360 divided by n, or 360 degrees divided by the total number of exterior angles in that regular polygon. And then finally, we applied some of this knowledge by doing a review question to find the measure of an exterior angle in a regular polygon whose sum of all the interior angles is 540 degrees. We found the measure of that exterior angle to be 72. So that's it for today's lesson. I know it was a lot of material to cover, but there's a lot we had to cover about angles in specific, so I'm glad we got it done with. I hope today's lesson was helpful, and I'll see you next time.